Vitamins.
Oh, all right. I'm like, you are a bold drug dealer, man. You're trying to eat. A couple money change in hand, and I'm like, wow.
From the spark plug.
Oh, they're samples, right? Drug dealer with a heart.
I taste the product first.
Well, if you ever were a drug dealer, you make no money sampling your own supply. Not that I'm an expert on that sort of thing. So where does the heat come from that acts on top of the piston?
Spark plug.
Ah, you long, but hold that thought.
Chemical reaction released on the fuel.
The heat's in the fuel. Yeah, it's the process of combustion releases the heat of the fuel. So one could say the higher heat value of the fuel would affect the performance of the engine. Okay, if I had a low heat value fuel, would I get the performance out of it? If I had a high heat value fuel, would I get the work out of it? Okay, so what is the engine's work? What do we call that?
Horsepower.
Ah, horsepower is what?
The value was working.
The rate at which work is performed. So if I had two trucks, one's loaded with lead and one's loaded with feathers, and you two are unloading the truck because you showed up late, you're unloading the lead, and you're unloading the trailers at the same rate, box for box. Who's doing more work?
We did a ton of feathers and a ton of lead.
Nope. Guys, I almost fell for that. Nope. You've got a 1 by 1 cubic foot of boxes. One box is full of feathers, and one box is full of lead. And you're unloading them at the same rate, box for box onto the dock. Who's doing more work? No, it's not.
We unionized.
The guy unloading the box of lead is doing more work. But you're the same horsepower because you're working at the same rate of speed. And this was the big thing when they first started pushing these engines on us. Oh, it's got the same horsepower as the diesel. Okay, that means they work at the same rate, but it's doing less work because it has less torque. It takes less torque. But it's the same horsepower. Okay, that's great. Now, if you were to tell me that engine, that natural gas engine made the same amount of torque as the diesel engine, that would be something to consider. But you're just telling me they work at the same rate. So the natural gas engine is unloading the box of feathers. The diesel engine is unloading the box of lead. They're doing different amounts of work, but they're doing it at the same rate of speed. Because if you remember the horsepower formula, part of figuring a horsepower, you've got RPM in it. And so RPM, rate of speed, how fast it's twisting. How fast it's twisting, not the amount of twist being delivered. Follow? Now, so we know the heat that acts on top of the piston comes from the BTU value of the fuel. What does the spark plug do? How? What about the spark plug ignites the fuel? Is it the pretty purple spark? What's that over there?
It sparks and it floods.
That's why they call it a sparky plug. Good. I'll put that as a choice on the test. What does the spark plug do? It sparks and plugs. Sounds kind of medieval, man. But it does. Sparks. What about the spark? What about that plug lights off my fuel air maker? Well, let me ask you this first. On a diesel engine, what lights off the air in the cylinder? Compression builds what? Heat. So I already have Boku heat in my combustion chamber and a compression ignition engine, a diesel engine. What do I do to force the piston down? So I got a piston sitting up here with Boku heat and pressure. I inject a volatile fluid into that excessively hot environment, and that volatile fluid busts and releases the heat in the fluid combined with the heat in the combustion chamber from compression, and it forces the piston down. Okay. On a spark plug engine, it's the heat of the electron jumping the gap at the tip that lights off my fuel-air mixture in the combustion chamber. That releases the heat of the fuel, forcing the piston down. So there's a couple of things you should take away from this. On a diesel engine, the fuel and air are mixed inside the combustion chamber. So on a diesel engine, on the intake manifold, it's all air. On a spark-ignited engine, the fuel and air are mixed outside of the combustion chamber in the intake manifold, and then sent into the combustion chamber as a mixture, where then it's ignited by the heat generated from the spark plug. Good on that? Any questions? Wow. What is compression ratio? Nobody? Brains are still thawing out. Not what it is. It's the amount of air in the cylinder when the piston's at the bottom of its stroke compared to the amount of air when the piston's at the top of its stroke. That's a ratio. 9.5 to 1 is typically kind of the norm. What are the 4 cycles that an engine has to go through to get a power stroke?
Intake stroke, compression stroke.
That's 2.
Power and exhaust.
Power and exhaust. Do they have to occur in that order? Absolutely. So that's a 4-stroke engine. How many times did the crankshaft rotate to get the 1 power stroke?
2.
2. Or 720 degrees. Right? Any questions on that? We good? All right. Today we're going to go into the lab. We're going to start removing our components. Okay, so we got a bunch of coffee cans out there. I think I got some duct tape. We'll label the cans with the height of the bolts that we're putting in there. I know one year I wasn't really paying attention and they put all the bolts from that engine in a big box. I was like, oh no, that's not good. So I spent about a half a day sorting out what was what. So we won't do that again. Because that was my fault. So we'll go out there and we'll start on the far engine over here by the window. And that'll be your AM engine, AM class. All right? All right, let's turn 2. Yeah, I come in there, I'm like, squish, I was like, oh, yeah.